So the second part of section 7.3 is now we're going to be translating on the t-axis. We did the s-axis for the first part of it. And there's a lot of applications for engineering. If you have some kind of mechanical system and external forces working on it, your system is either going to be off or on. So depending on where it's at, we're going to use this function, the unit step, or Heaviside. And it's called the Heaviside from the mathematician Oliver Heaviside, who is the one who came up with this. So the definition, we use the script U, just like we used that L for the Laplace. And this time we're taking our T and we're translating it. And we're going to get 0 if T is between 0 and A, and then we get 1 when T is greater than or equal to A. So 0 means my function is off, and 1 means my function is on. So we'll look at not just the basic one like this, but they can be translated in different ways. But this is just the standard basic one that we're going to start with. Okay, so our first example, and there's tons of examples in your notes from Blackboard, but I'm not going to do them all because of time. But I definitely want to make sure that I do a few of each one. So I am doing some of the examples in there if you have that material printed out. So if we have the unit of t minus 4, and it's 0 if 0 less than or equal to t less than 4, because that's all what that A term is built off of, and it's 1 when t is greater than or equal to 4. So for this, if this is my 4, then it's off because it's 0, starting at 0 over to 4, and then we have an open circle there where A is, and then it's on at 1. So this is 1, and that's what the second part of my function looks like. So this time I have 5 times the unit step function of the t minus 4. So it's still going to stop and go from one to the other at 4, but it's going to be 0 when t is between 0 and 4. And now because there's that 5 multiplied out front, it's going to be 5 when t is greater than or equal to 4. So I'm still going to find 4. That's where it goes from one step to the other. And I have 0 up until that 4. And then this thing is going to jump up to 5. And that's going to be closed in up here as we go on from 4. So the unit step can be steps like this, but it also can be functions, not just steps that's multiplied by it. So I have t squared times the unit function of t minus 1. So it's still going to be 0, but then when you multiply that bottom 1 up here by a t squared, then this bottom part is going to give me a t squared. And this time my a value is 1, so I am at 0 less than or equal to t less than 1, and then t greater than or equal to 1. So it's going to look a little different when I graph this one. So from 0 to 1, it's equaling 1, and then once I hit 1, it equals t squared, so it's parabolic. And that's what the second piece looks like. Okay, now I want to rewrite some more functions that aren't necessarily of the same type. So I'm going to skip down a little bit from your notes. And this time we're given the graph. And we have to write the function. So the piecewise function. So I have this value is 2, sorry. So I have f of t is 2 between 0 and 3. So it's on there. And then it's 0 when t is greater than or equal to 3. So, well, how can we write the unit step function when it has something like that? Because it's not exactly the way we had it before, right? And I want to use that notation. So f of t is going to equal just 2. And then minus, I have to have a 2 in front because these two are just going to cancel each other out. So minus 2 times the unit step function of t minus 3. So I have a function now that's on first and then it's off. And I'll do one more of these before we get into the theorems. So g of t is equal to t plus 1 when between 0 and 4, and it's equal to 0 as t is greater than or equal to 4. So t plus 1 is just a linear equation starting at 1, and the slope is 1. So when it gets up here to 4, then that should be 5 there. So that's my first piece. I don't know what I did with my other marker. That's okay. And then it's off. So at 4, then we're just going to go over. So what do I have first? I have my g of t is equal to t plus 1. That's when it's on there. Minus t plus 1 times the unit step function of t minus 4. So this is going to be our second translation theorem that we're going to go through and do some problems, but I think I need to stop, so I'll start another video.